get started. First of all, does anybody have any questions that they want to go over? Specifically 9.4, 9.5? Or any section in chapter 9? Okay. James Mackenzie, how are you guys doing with these sections? Cool. Well, that's good. I'm glad everybody doesn't like them. Oh, that's right. I'm going to try something out here. See if Desmos is as cool as I thought. It is cool. They're so lucky to have Desmos. Feel lucky. All right. Okay. Did you blow their mind, Elijah? Elijah said he showed someone who had only ever used a graphing calculator. Yes. Now, if someone could figure out, I'm sure Desmos is working on this, right? But if somebody could figure out how to take Desmos and put it on a device that could be sold and used in like standardized testing and high school and college courses where you obviously can't plug a phone in, then they will be making a lot of money. Because the TI calculators are still like $90. So not that they're they're still great calculators, but Desmos is free. I know, that's what I'm saying. I would hope that Desmos would be working to that. Right? Yeah. Like I said, I'm sure somebody can figure it out. It's just they have an app already. They have a website already, but I don't know. I haven't looked up if a calculator that could be used, and I don't know how you go about getting approved to use them SAT or ACT or in college classes or whatever. So, but I do, right. I don't know. I do read math teacher blogs. And that was a nerdy statement, I admit. And Desmos is definitely becoming the new standard. So, don't you guys read math teacher blogs? Totally awesome. Come on. All right, so we should get to work. It's 9:09. I want to keep you all here all day, right? Are you trying to distract me from the last two sections? Daniel, did you have two questions you wanted to go over? Yeah, all right. What questions did you want to do? All right, 25 and 31. I'm reading your comment, Elijah. Are you typing? What section is that? 9.4 or 9.5? Nine five. Sorry, that was random coughing. I at least remembered to mute this time. Okay. 9, 5, 25. Okay, so we are in the hyperbola section. And let's see, let's throw up paint here. Okay, so this is 9, 5, number 25. And what they're doing is they're giving you some points and they want you to write an equation of a hyperbola given the foci and the vertices, right? So we've got, they actually tell you what the foci are at -3 square root of 6 and 0. And the other foci is at 0. Nope, I wrote that wrong. Go back one. I'm like, that's not right. You can't have foci at 2 different axes. Okay, the other one is at 3 square root of 6, 0. And the vertices are at -2, 0, and 2, 0. Those are easier to write. Okay, so the first thing that we have to do, I am recording, I think. Yep, I think. Yes, I'm recording. Okay, thank you for checking. So the first thing that we have to do is we have to figure out, we know that we're in the hyperbola section. So we know it's a hyperbola. And we're trying to make an equation for a hyperbola. So we got that down. We have to figure out if we're dealing with a horizontal hyperbola or a vertical hyperbola. Okay? And the way that we do that is we look at, well, where is my foci and my vertices at? You don't have to exactly know where they're at, but we know that the vertices or the vertex is at -2, 0, and 2, 0. And the foci are out here somewhere. So that means that our two competing parabolas are going to open up like this. So just by kind of looking at my points, right, I can say, okay, this is a horizontal hyperbola. So if it's a horizontal hyperbola, I want to use the equation x squared divided by a squared minus y squared divided by b squared equals 1, right? So that is my equation for a horizontal hyperbola. Elijah said, are we just putting in an equation that passes through those locations? Yes. Yeah. So you want it to make sure when you graph it, that's where the vertices need to be. Okay. So we've got that. We also know, just like ellipses, the distance between the two foci to the ellipse are equidistant. We also have a relationship with the distance between the foci and a hyperbola. So what I mean by that is the distance from one foci to the hyperbola to the other foci. It's a little bit different. So that distance is a constant when you subtract them. Okay, so we say that these foci points, which are C, are, I'll read which, C squared equals A squared plus B squared. Elijah, you're saying you got to break out of your geometry brain. Why get to break out of your geometry? Oh, it is a triangle. Look at you. And guess what? What does this look like? Pythagorean theorem. C squared equals A squared plus B squared. It is kind of backwards, you're right. But it does look like a triangle. Well, you can go either way. That's funny. Daniel asked me that on Monday. He's like, why isn't it A squared plus B squared equals C squared? Well, you can do it either way. Okay. So we've got all of this like X, Y, A, B, C. We've got all these things going on. What corresponds to what? Well, our vertices, our vertex, are our A's. That's where our main point is on our parabola, right? So that means that A equals 2. And our foci, especially if you refer back to your chart that you have, we know that our foci aren't B, because B is actually some point out here. Yeah, B is a point out here that actually helps us find our asymptotes. But we actually in 25, we don't even have to find asymptote, so kind of look out. So the foci isn't B, the foci is C. So C equals 3 square root of 6. I'm just going with the positive values. You could go with the negative values if you want, because if you notice, all of my equations are squared, so that negative sign is going to kind of get kicked out when you square it anyway. Okay, so really the equation that I'm looking to find is this equation, but in order to find B, I need to use my second equation first. So that's what we're going to do. And I'll write it this way for you. A squared plus B squared equals C squared. So A squared we know is 2 squared plus B squared equals 3 square root of 6 squared. Yep, the 2 is still squared. Okay, so 2 squared is easy, obviously, that's 4, right? B squared. Okay, so what about over here? 3 square root of 6. Well, this is the same as 3 squared times 6. Your review of your square roots over there, right? Because if you apply the square to each one, you have 3 squared, and then the square root of 6 squared is just 6. So when we do all this, we get 9 times 6 is 54 minus 4. So I end up getting B squared equals 50. I think I did that right. You guys check me. Did I do that right? Check my algebra. I think that's right. Okay, so then now what do I do with the B squared? Nope. So Elijah, so when you do 3 squared, 6 squared, what that's like is you're going to take 3 squared. Here, let me move over here. So you're going to get, yeah, you're going to get 3 squared times 6. The 6 kind of gets left alone because it already had the square root on it. So then you do this 3 squared, which is 9 times 6. So 9 times 6 is 54. All those math facts a long time ago, right? So you end up with 4 plus B squared equals 54, or B squared equals 50. Your calculator didn't do it right. Yeah, type it in there right. Did you use Desmos? Yeah, that won't work. So if you go like this, ignore all that stuff, right? 3 square root of 6. And then you got to get that parenthesis outside the whole thing, squared 54. So if you did that, oh, no, you got to subtract 4. So you have 4 plus b squared equals 54, then subtract 4 from both sides and get 50. And Elijah said, oh, if you do 3 times 3 times 6, it doesn't work. Huh, it should. Okay, so let's get back to our equation. Are we ready to write our equation now? Yep, to get rid of 4, you subtract. Exactly, Elijah. So we're ready, right? We've got A, we've got morning, I know. Making you think at 9 in the morning. Okay, so if we write this equation now, we have a squared and we have b squared. So our equation would be x squared divided by a squared. So it has to be 4, right? Minus y squared divided by 50 equals 1. Okay, this would be your equation. This would be your equation for the hyperbola that passes through that point. I think it's easy to solve. Okay, what was the other one? Sorry, I lost it in there. 35? $33. I'm not following that, Elijah. X squared to 8 and y squared to 50. Oh, and before I forget, you can throw it in Desmos and make sure it looks like the hyperbola that you were hoping that it would look like, right? So we've got x squared divided by 4 minus y squared divided by, if you type it in there, right? Divided by 50 equals 1, if I could type today. Okay, so there's our nice hyperbola. And I don't, oh, wait, we did, what is 3? 3 square root of 6 would be about, let's see, about at 6 and 6 something. So this seems right because, right, your parabola is a pretty big parabola, so that means that your focus point should be out pretty far. Like if your focus point was in really close, you would expect your parabola to be much shorter. Okay. Elijah says 33 isn't one of the homework. I am happy to do that one if you want to, but $33 is a short response. So I don't think I would have assigned that. All right, so it's probably a good time to get on to the next section, even though you guys were hoping that we would spend the whole time reviewing, right? I know if I was you, I would be thinking that. No, not us, right? So, oh, sorry. You don't have to do 33 and 95. And if you did 33, go ahead and turn it in and let me know. Okay, so we are in section 9.6. So we definitely want to use today to go over 9.6 because This section is called Translate and Classify Conic Sections, right? Elijah asked if all of those sections are due on, when are all those due? They are not due this Monday, they'll be due the following Monday. I was hoping to wrap up chapter 9 today. We'll see how far we get, but I don't expect you guys to finish all your chapter 9 homework just this weekend. So I'm going to give you until April, I don't know what date that is, April 3rd, something like that. April 3rd, there you go. Get till April 3rd. Okay, so first of all, conic sections, we haven't actually labeled all these, but we've talked about, you'll see the list here, we've talked about circles, parabolas, ellipse, and hyperbola. We've talked about these 4 things. In Algebra 2, those are called conic sections. So I didn't tell you that up front, but you guys have learned all about the properties of conic sections. Aren't you impressed? So now if you see that somewhere and you have to learn about conic sections, you're not like, I've never seen that before in my life. You actually have seen it before in your life. Conic, yeah. Yes, now you are enlightened as to what those are. So we know that when we did all those sections before, I kind of pointed out to you, we had it nice because all of our circles, parabolas, ellipses, and hyperbola had a center at the origin. They were at 0, 0. Okay, and so what this section does, 9.6 says translate and classify conic sections. So what translation means is that we are going to be moving our circle or our parabola from having a center at 0, 0 to having a different center point. Okay, and you can see it here. I think I stole this straight out of your book, but yes, I stole it right out of your book. In the following equations, the point HK is the vertex of the parabola and the center of the other conics. So really, what we're talking about is before our H and K, those are 2 just other variables, we're at 0, 0. So if you remember our equation for a circle, let's turn on the whiteboard here. Our equation for the circle before was just x squared, so we didn't have the h, right, because it was 0, x squared plus y squared equals r squared, right? But now we actually have an h and a k that can translate where our circle is centered. Okay? Same with the parabola. Before, when we did parabolas, right, it was just y equals, do you remember 4 times p? Remember we found the p? Times x. So basically, we're just adding in this. You guys are so silly. This is not that hard. We're adding in an additional part. So ellipse was x, well, a horizontal ellipse was x squared over a squared, y squared over b squared equals 1, right? Hyperbola was x squared over a squared minus y squared over b squared equals 1. So all we're doing, it's not hard, right? It's just the y, because if this is the y, let's see, I don't want to save that. I'm going to clear that off. No, hit the wrong button. There we go. Okay, so this is the y. What if you need to draw a circle and it's not at the center? So actually Desmos to the rescue, right? Has these nice little sliders that you can play with. All right, so this is the equation for a circle, right? X minus h squared plus y minus k squared equals r squared. Okay, so before, what I was saying is we assumed that this h and k were 0. And because they're 0, we're not translating our circle anywhere, right? And this circle has a radius of 1. So we can make it have a radius of let's make it have a radius of 3 to make it a little more exciting, right? So if you want to move your circle, right? Let's say we want to move our circle to the right to a point at 5. How would we do that? Do you think we need to do something to the x value or the y value? So Elijah's saying you want to add 5 to x. So that would be this h value, right? There we go. And actually, you're super close. You want the h value to be 5, or change the slider. You want the h value to be 5, Elijah, because that's what goes to your x term, right? But notice it's subtraction. Yeah, close enough, right? So then what if I wanted my center of my circle to be at 5, 2, right up here? So I need to translate my circle 5 points to the right. Sorry, coughing again. Yeah, that's the kind of weird part, right, Elijah? You're picking up on that. So if you want to move it 5 to the right, you actually subtract, which is kind of weird, right? Like, why would you do that? But it kind of makes sense when you put numbers in there. All right, so if I said that, so what Elijah is saying is my h value is 5, but that means in my equation would be x minus 5, like this circle right now would be x minus 5 squared plus y squared equals 3 squared. Okay, that's what this kind of all means. So why would that put it at positive 5? So if I put into my equation x equals 5, which is where we're at, right? X equals positive 5. Then what happens here is I get 5 minus 5, which is 0 squared. So that means that I'm staying right here at the origin. Plus y squared equals 3 squared. Yeah, 0 squared is 0. Okay, so I think you guys probably figured this out. If I want to move this circle to 5, 2, I need to move my y component up by 2. Okay, and this works for all of our equations. So let's leave that one up there. I don't know if Desmos is going to let me do this. And actually, if you remember a few help sessions or calls ago, we talked about this, and there was already a preset Desmos for parabolas. Parabola Desmos. Oh, Parabola Desmos art. How cool is that? That's not quite the equation we want to use. So there's different versions of this. Let's see. All right, well, I should just type it in. All right, so the equation for a parabola is back here. We have y minus k squared equals 4p times x minus h. We're going to do horizontal. We'll just worry about horizontal, okay? So we have y minus k squared Okay, so now we have a parabola up here, and we're kind of sharing the same sliders, right? So let's start our sliders back at 0, 0. Okay, so this is how we, and remember P is just that constant that kind of helps us figure out how big or smaller parabola is going to be, right? So let's just set that at 1. Doesn't really matter where that's at. All right, so if I have a parabola, the standard equation, if these are 0, so y squared equals 4p times x, right? If I want to move my parabola to have the vertex instead of the vertex of the parabola being at 0, 0, and I wanted to move it to 5, 2, what do you think I would do? I would move my y value, right, up to 2, and I would move my x value, which is h, over to 5. And we've got the circle that's coming along with it. So I think it's pretty straightforward. It looks really intimidating. If you look at the sheet and you're like, what is going on? I don't know how to do all that, right? But you actually do. H and K are just what is moving your circle, parabola, ellipse, hyperbola. So basically where the new vertex or the new center is. Okay? So what the homework is, there's not much homework for this section, actually. Is what you're going to do is graph the equation, identify the important characteristics of the graph. Okay? So what do I mean by that? It's just as hard as the other sections. Not that hard, James. I promise. All right, so let's look at this first one here. Okay? Number 1, we have x plus 1 squared plus y minus 3 squared equals 4. So before I even just go straight into Desmos, does anybody know what this is the equation for? Is it a circle, parabola, ellipse, or hyperbola? It's a circle. Oh, someone said it was a circle. It's a circle, right? It just has this extra h and k, but it's still the equation of a circle. So before we even go to Desmos, like realistically, you should be able to just to say what it is, right? Yeah, maybe. Okay, it's a circle. The radius squared is 4, so that means it has a radius of 2. So we're going to try to do this without Desmos. We're going to be really, really cool to do it without Desmos, right? Has a radius of 2, okay? The x is being translated by plus 1. So what we learned when we were playing with Desmos a minute ago, and I can send that out so you guys can play with Desmos some more if you want. What we learned is when we subtract something, it moves to the right. So when we add a plus 1 here to x, it's going to go to the left. So I know that my center of my circle isn't going to be at 0. It's going to be at negative 1. And then the y value is minus 3. So that's going to be at positive 3. So I think my circle is going to have a center at negative 1, 3. And that's just based off of knowing that x is being added by 1. And we know when something's being added, that moves it to the left. And when we subtract, that means that we're moving in the positive direction. So we're going to move x positive 3. And then we know it has a radius of 2. So that means there's a point here, a point here, point here, and a point here. And that's what my circle should hopefully look like. Okay, so if I go into Desmos now, and I try graphing this, what do I have going on here? It is fun. So is x plus 1 y minus 3, and the radius was 4. I get rid of all this crazy stuff that we got on here. Clean it up a little, right? Oh, if I could just move my other graph here. Let me see. Can I move this graph around? Look at that. Like awesome, right? So yes, we have our circle, right? Its center is at -1, +3, and its radius is 2. So back to the original problem, graph and identify the important characteristics. Well, you could graph it without even Desmos, right? But you'll probably use Desmos. So what would the important characteristics of a circle be? That's the question. So the important characteristics to note would be that the radius is 2, right? And that the center is at -1, +3. That would be the important characteristics of that. So now is that hard? Nobody's talking. They're reserving their right till they actually do the problems to tell me if it's hard. Nah. The section's not that bad, right? All right, so let's do another one. Find some short, easy. Yeah. All right, so. Aw, enjoy your visit with your grandma. It's recording so you can come back and watch it. Okay, so number 2, we have x minus 2 squared equals 8 times y plus 3. All right, Elijah, you're the center circle finder. All right, so what about the second one? Is this another circle or is this a different thing? This is a parabola, right? We don't have this nice x squared, but we're not dividing by anything, so by process of elimination, we know it is a parabola. Now, is it a horizontal parabola or a vertical parabola? This appears to be a vertical parabola, right? So the thing with parabolas is we need to know if it's a horizontal or a vertical parabola, right? If it's a vertical parabola, that means it's going to open up in the air, right? And so we need to know where is the vertex of this parabola going to be. So let's look at what's happening. I should have left my amazing graph up here. Let's see. Okay. Or I should just have some graph paper. Okay, so we know that the x is being subtracted by 2, right? So it's being subtracted by 2 or being translated by 2. So that means that my new vertex of my parabola is going to be at +2. So it's like the opposite sign when you go to graph it, right? So we know it's going to be at +2. We also know it's being translated on the y-axis, and it's y plus 3. And you'll see the original equation is y minus k. So since we have a plus here, that actually means it's going to translate to negative. So it's going to be 1, 2, 3. So my new vertex of this parabola is going to be down here at +2, -3, right? It is also, we should know from parabolas, right, that since this is a +8, this parabola is going to open up and it's vertical. So it is going to look something, this one's not going to come out as good, I have a feeling. It's going to look something like this. Okay, so if I go to Desmos and I graph it, I get x minus 2 squared equals 8 times y plus 3. There we go. Quite as good, but this is pretty good. Oh no, my parabola was too fast, right? But my vertex is at 2, negative 3. So we got that part right, right? What if we wanted to find out where the focus point is? Do you remember doing that homework? Well, actually, let me do one thing first. So one of the properties, the important characteristics, right, of this parabola is that my focus is at 2, negative 3. So I think we all got that, right? Moves around. What about my, I keep saying the wrong thing, my vertex. Why am I saying focus? Because I'm thinking ahead to the next thing. I apologize, erase that from your mind. My vertex, not my focus. I was thinking, I wanted to tell you guys where to find the focus, and I wrote focus. Okay, my vertex is at 2, 3. I hope I was saying that wrong the whole time because I was thinking about the focus point. The focus point, right, is what it moves about. So how do I find my focus point over a parabola? So if you remember, the focus point is P. So it's where 4P equals, and we have right here, positive 8, right? Or where P equals 2. So my focus point, is it at 0, 2? Or do you think it gets translated? So do you think my focus point is at 0, 2 up here? Or does it need to get translated over to 2, negative 3? The chat is silent. So your focus point actually gets translated too. So you wouldn't have your vertex down here and your focus point at 0, 2. You wouldn't have your focus point up here, right? You guys following along with what I'm saying? You wouldn't have a focus point up here. Your focus point is actually going to get translated as well. So the focus gets translated, x equals positive 2, so 1, 2, and negative 3. 1, 2, 3. So your focus point is down here at 2, negative 1. So that's kind of the only little tricky part, is that you have to translate your other pieces too. You made the parabolas move. I don't know, did you? All right, if math is cool, I'm all for it. I am with you. Math is cool. Okay, so I think we probably have time for one more. And then there is one last thing I wanted to show you, kind of to wrap up this whole idea of conics and why they are called conic sections. And I wish I had that up. So do you want to do example 4 or 5? One's going to be a hyperbola, one's going to be an ellipse. So Let's do the ellipse. How's that sound? So this is an ellipse. We know it's an ellipse because we have a plus sign here, right? And if you remember, let's see, is this going to be let me see if I can get them both on the page at the same time. Oh, barely there. So is this going to be a horizontal or a vertical ellipse? So I think this is going to be a horizontal ellipse because 16 is a bigger number and it's under our x. So I'm saying it's a horizontal ellipse. So without this x minus 2 and x minus 1 business, right? If we were just going to quickly graph this ellipse, we would know that the focus points, because this is 16 and the square root of 16 is 4, so the focus points are going to be at 4, 0, and negative 4, 0. And the co-vertices are going to be at 0, 3. And that's just based off of the numbers 16 and 9 and the square root of those. So this would be my ellipse without it being translated. Okay, but we are not just going to stop there, right? We're going to actually translate our ellipse. And so we translate it by x minus 2. So x minus 2 means that the whole thing is going to shift. Come on. Trying to do something there. Here we go. The whole thing is going to shift by 2 to the right. Right? So it's going to go 2 to the right. And the y is minus 1. So y is going to shift, that's the wrong direction. Y is going to shift up positive 1. All right, so both of my points here, I should have really drawn this to scale. Sorry, you have to suffer through my bad graphing. Okay, so my new vertex is going to be at, shift from 4, 0, so I'm going to shift it to 6, 1. Okay. And my new co-vertex is going to shift from 0, 3 to 2, 4. Yes, it's still 6, 6. So it's actually going to shift everything over 2 to the right on the x-axis and up 1. So if I go to draw my ellipse egg, it's going to be shifted up a little bit. All right, so let's see if we actually did this right. Right, when we go into Desmos, we had x minus 2 squared divided by 16 plus y minus 1 squared divided by 9 equals 1. All right, let me do something really quickly too. Take out the shifting graph here. So turn that off. Okay, so the orange is my original ellipse, right? A standard ellipse. And then the green is when we shift it. So you can see that we went from having a vertex of 4, 0 to having a vertex of, oh, Desmos doesn't like to find it like that. That's not nice. Yikes. It gets really mad right there at 6, 1. Why does it get mad right there? The undefined virus. I'm just thinking, why does it get mad there? Because we're not dividing by 0. I don't know, I have to get back to you on that. Yep, it's getting mad right there. But that does show you where, yeah, where it's shifting to. All right, well, maybe the covertex will be a little nicer to us. Oh, the covertex is a little nicer. So you can see the covertex actually did shift to 1. So this is the question for you. Where is the new center of my ellipse at? So my original orange ellipse is always centered at 0, 0. So where is the center of my new green ellipse? Well, the center would be the same thing that we did for everything else. Shift it over 2 and up 1. So the center would be at 2, 1 right here. Okay. So that is the excitement, which is translating conic sections. Nope, I keep hitting save. I mean to hit clear. All right, I know I have like 4 minutes. Give me 1 second to pull something up because I actually think it's cool. I know, math cool, but still cool. Let me pull this up really fast. Oh yeah, there's some really cool videos out here, but I just want to show you this. I had a really cool website for this and I can't find it, but this is just going to have to do. Okay, so remember when I said these are called, and I don't even know what this website is, but yes. Remember when I said this is called conic sections and you said, why is it called a conic section? Okay, so these are actually 4 conic sections. Okay, and this is where we get our 4 shapes that we were just talking about. So the first, so these are conic, you know, a cone, right? So the first conic section that I think is easiest to see is if you split a conic section. You can't see anything? Can you see it now? Yeah, you can see it now. If you split a conic section exactly parallel to the center, right? This is at a right angle. So you're perpendicular to the center of a conic and you split it, you're going to get a nice circle. Okay. If you split a parabola, or sorry, if you split a conic section, kind of slice it this way, you get this parabola shape. Okay. If you split a conic section at an angle this way, you're going to end up with an ellipse. And then if you split the conic section and it goes through both sides of the conic, you get this hyperbola. So that's actually where these shapes come from, and that's why it is called a conic section. It's not just like a random math term. It's because you get all of these shapes out of by dividing a conic section, a cone, basically. And actually, if you want to see a prettier picture, I think your book has a prettier picture on page 649. And you can do it. You can even do an exciting exploration activity using a flashlight. On a piece of paper, draw an X and Y axis. Model a circle and an ellipse using your flashlight. I won't make you do that, but I just did want to kind of bring it full circle and explain why it's called conic section and where all those shapes come from. Okay, 1 minute to spare. We're done early, right? Yeah? Yay. Oh, now it's 10 o'clock. Sure. Okay. Thank you guys for sticking with me today. We still have 9-7 to finish. You actually could get started on 9-7 because we talked about it a little bit on class on Monday. So if you're really motivated to get all of your chapter 9 homework done, you could do that. 9-7 is the one where you have systems of equations and you're solving. So, but But if not, we will go over more on Monday. So thank you guys for coming today. Hopefully that was helpful. Hopefully you have fun playing with Desmos. And I will talk to you guys on Monday. Have a good weekend.